In this lecture, we'll explore encoding and decoding context both with and without attention. Previously, we learned how models like word2vec identify relationships between words. However, the same word can have different meanings depending on the context. For example, the word bank can refer to the side of a river or to a financial institution. These meanings are completely different, so we can't treat them as the same. To understand the correct meaning, the model must consider the entire sentence. That's where context and later attention mechanisms become important. Let's first discuss the process without attention. Imagine translating a sentence from English to French. Take the example, I love llama. In a traditional sequence-to-sequence model, the system processes each word one at a time. First, the words are converted into vectors, as we discussed earlier with embeddings, because neural networks can only work with numbers. These vectors are then passed to the encoder RNN, which captures the context or meaning of the input sequence. The decoder RNN then takes this encoded information and generates the output. In this case, the French translation. The model processes the words step by step first. I then, love then, llama. Each step depends on the previous one. For instance, love might correspond to 2 words in French, so the decoder needs to remember earlier parts of the sentence to generate a grammatically correct translation. However, this step-by-step approach has a limitation. When sentences become long, the model may forget earlier information, leading to inaccurate translations. This is where attention comes into play. It helps the model focus on the most relevant parts of the input while generating each word in the output. In the next lecture, we'll see how attention mechanisms solve this problem more effectively, especially for longer or more complex sentences.